0 first, second, right?
Yeah.
So, well, let's make one more spot right here. So let's say we have our linear equation. Okay.
Mm-hmm.
We have our half-life.
Yeah.
We have what our half-life is saying. So like, we'll just say an example of a half-life. And then last, let's do the graph associated with it.
Okay.
So with these three things here, you should be able to do it. Rearrange them however, pick through equations, you should be able to solve anything. That has to do with first order. Second order, third, zero order, linear
equation?
Mm-hmm. Or half-life, right?
Yeah.
So, linear equation, do you remember it?
No.
So A, this is time, equals K, negative KT, plus A naught.
Okay.
First order, well, let's just keep going with zero. So the half-life, we know that we just have this, and it's over 2K equals our half-life.
Okay.
And then the graph will have just the concentration of A to time, and it'll be straight.
It'll be straight. Okay.
Okay. So as time goes on, the concentration
Goes on.
decreases, right?
Yeah.
Okay. So next, first order, we have what we just did, ln of A over A, this is time, this is initial, equals negative KT. So here we see we're dealing with ln's. So let's go to here. So our half-life equals ln of 2 over K. So ln, our graph, whoops, follow the trend, ln of A, first time. Okay.
And the ln of A is just ln of A. It's not of like initial or time or anything.
So it's going to be at each point. So let's say like you have this much after 32 seconds. So plot it. So you say ln of 20 versus your time, which is 32 seconds. So you have to solve this. So let's say it equals like 5. So then you'd go on your graph. So at a concentration of 20, it's going to be, on here it'll just be 5 though.
Okay.
So we're dealing with the same concentrations in each of these, but one of them, because we changed like ln, and here it's going to be 1 over A. Since they do this little change, one of them will be linear and the other ones won't.
Okay.
So like all of these, they could say, give you the same plot of data, like this, and say, here's our time, here's our concentration. But then, so for zero order, they're going to take these points exactly, plot them. But this one, they're going to do ln to all of these, and then plot it. In this one, they're going to take the concentration and do the inverse of it, and then plot it. And then whichever one gives you the straight line, that's what order your reaction is.
Okay.
So if you plotted all the data and this one came out a curve, this one came out straight, and this one came out a curve, you'd say, oh, it's first order. And so the reason this one goes up is because you're doing the inverse of A. 1 over.
Oh, yeah. Okay.
So, yeah, because like these ones are going to just be straight across. Like, smaller A will go down. It'll get smaller over time. Whereas 1 over A, so like 1 over 1 versus 1 over 2. 0.5 versus 1. So a smaller concentration here give you a bigger number. That's why it goes up. So like normally you would think it would go this way, right? Because you're
Yeah.
decreasing concentration. Anyway, it just goes up for this reason. Because you're putting the concentration on the bottom.
Okay.
Side note. Okay, so let's look at this. We know we're dealing with A in the denominator. So 1 over A time equals KT plus 1 over A initial. There's that. Then we know we're dealing with the denominator, so we're going to keep that trend. And we're going to do 1 over A. Or not 1, sorry. 2K over A. Oh, that's what it is. So it was 1. So 1 over K. So then, if you kind of get this in your brain, oh, and your example, well, your idea of this is, so your half-life is gonna, or your, so we have our concentration here. Oops. First time. So when we think of just first order, our typical half-life, we say we started with 100 grams of something, and each half-life is 5 years. Okay? Each time it happens, what's going to happen? If you just think of a normal half-life.
Every 5 years it'd be 50. I think it was 25.
Yeah.
And 12 point whatever.
Mm-hmm. So that's your, it remains constant. We'll just put that for now. Okay, but when we go to zero order,
That one's half, isn't it? Or no, it's double.
so this one's halved.
It's half, I knew it.
So, yeah, so we started at 100. So our half-life is every 5 years, right?
Mm-hmm.
But the first time it's 50. But then the next time it happens, sorry, this is wrong. So you half to 50 and then 25. But the first time it's 5 years, the next time it's 2.5 years.
Oh, so the time changes.
Mm-hmm.
That makes more sense.
Because if you think of a half-life, what they're saying is that, you're halving each
Yeah.
time. But the thing is, at the rate that it happens is different for these orders. So zero order, it's going to half your time. Halved. And then this one is going to be doubled. In other words, we're saying we have our concentration here, our time. We do 100, 50, 25. So the first time it took 5 years.
Next time it'll take 10 years.
The next time to half, it'll take 10, 20, 40.
That makes so much more sense now.
Yeah.
Because I was thinking that it had to do with the reactant, like the product, the half-life of whatever.
Yeah, so half-life.
So I was thinking I was thinking that's.
Were there questions on that?
What?
Was there a question on this?
There probably was. I don't remember it. Ouch.
So your half-life is going to half.
The time.
Mm-hmm.
Okay. Cool.
Because half-life, all they're saying is it's half of a life. So you have to half its life each time, which is this.
Yeah.
Yeah.
But then the time on the zero order is half,
Mm-hmm.
and if it's on the second order, it's doubled.
Yeah.
Okay.
So the time it takes to half, yeah.